All right, today we're going to tackle a question that sounds like it's straight out of a sci-fi movie, but trust me, the science behind it is absolutely mind-blowing.
Just picture this for a second. You look up at the night sky and it's just empty. That familiar, comforting glow is gone. So what would really happen if our moon just, poof, vanished?
Now you might be thinking, okay, so what? Darker nights, maybe the tides get a little weird, but oh, it's so much more than that. The reality is, it would be a catastrophe. For 4.5 billion years, the moon has been this silent guardian, this architect of our planet's stability. Take it away, and Earth becomes, well, a place we probably wouldn't even recognize.
And the first biggest change wouldn't even be in the oceans. Nope, it would be in the way our planet literally spins. We'd start to lose our balance big time.
You know our seasons, right? Summer, fall, winter, spring, that lovely predictable cycle? Well, the only reason we have them is because the Earth is tilted on its axis by about 23.5 degrees. That little tilt is everything. It's why different parts of the planet get their turn to be warm, and it's basically the foundation of our entire global climate system.
So what keeps that tilt so nice and steady? You guessed it, the moon. Its gravity is constantly pulling on us, kind of like a steadying hand on a wobbly spinning top. It keeps us from just tumbling all over the place. Take away that hand, the top goes crazy. Take away the moon, and so do we.
Okay, and this is where things get really fascinating. We know it would be bad, but scientists are actually debating just how bad. There are two main theories here, two competing models.
So in one corner, you have the Lasker model from '93. This one predicts total chaos. It says our tilt could swing from 0 degrees, like no seasons at all the way to a frankly terrifying 85 degrees. But then, in the other corner, you've got a more recent model from Lissauer and his team. They think it'd be more moderate, maybe wobbling around 20 to 25 degrees. The key thing, though? Both models agree the moon is our anchor. They just can't agree on how rough the storm would be without it.
But let's just think about that worst-case scenario. 85 degrees. Can you even picture that? Our planet would basically be spinning on its side.
In that world, the North Pole wouldn't be ice and snow. It would be pointing directly at the sun for months, just baking in this blistering, non-stop heat. And at the same time, the South Pole would be in absolute freezing darkness. The temperature swings would be so extreme, they'd create winds you can't even imagine, just scouring the surface of the planet.
All right, so on top of that chaotic wobble, the length of our day would be completely shot. We'd be living life in the fast lane, literally.
We take our 24-hour day for granted, right? But it wasn't always this way. See, the moon's gravity pulls on our oceans, creating this bulge of water. And as the Earth spins, it tries to drag that bulge along with it. But the moon keeps pulling back on the bulge, and that acts like a brake, a giant cosmic brake that, over billions of years, has slowed our rotation down from just a few hours to the 24 we have today.
But here's the kicker. It's not just the moon. The sun is in on this too, but it does the opposite. The sun heats our atmosphere, which creates this thermal tide that actually tries to speed us up, giving us a little boost. Right now, the moon's brake is way stronger than the sun's accelerator. But if you take the moon out of the equation, that little solar boost suddenly takes over.
So, if we never had a moon to begin with, our day would likely be somewhere between 6 and 10 hours long. Just think about that. The sun would rise and set maybe 4 times in what we now call a single day. Our entire biology, our society, it's all built around a 24-hour clock. A 6-hour day, it would be chaos, completely unsustainable.
And a planet spinning that fast would be violent. The difference in speed between the equator and the poles would whip up the atmosphere into a frenzy. We're talking constant, planet-wide winds over 160 kilometers an hour. It would be like living inside a permanent global hurricane. Okay, let's talk about the oceans, because what happens there is just as wild. Seriously, we're talking about completely redrawing the map of the world.
Right now, the moon's gravity is pulling up a massive bulge of water around the Earth's equator. It's about 8 kilometers high. If the moon just disappeared, that entire bulge would collapse. All that water, a colossal amount, would rush towards the poles. What you'd end up with is a brand new supercontinent all along the equator, while places like Northern Europe, Siberia, Canada, they'd just be gone, drowned under a much bigger Arctic Ocean.
And it's not just about where the water ends up. It's about how it moves. You see, the moon's tides provide about half of all the energy that powers the Great Ocean Conveyor. You know, that giant system of currents that moves heat all around the planet. It's like the world's circulatory system, and it's absolutely vital for regulating our climate.
So you take away that lunar energy, and that conveyor belt just stops. Northwestern Europe would plunge into a deep freeze. We're talking a drop of 5 degrees Celsius. The deep oceans would stop churning. They'd become stagnant, lose their oxygen, and turn into massive dead zones. And the marine food webs that billions of people rely on, they'd just collapse.
So the physical changes to the planet are just staggering, but the impact on life itself, just as big. For basically all of history, life has been dancing to the moon's rhythm. It's our planet's metronome.
Think about it. The massive coral reef spawning events, that's triggered by the full moon. Lions in Africa, they hunt best in the dark of the new moon. Baby sea turtles, they find the ocean by following the moonlight on the water. You take away those cues and suddenly reproduction, hunting, navigation, it all starts to fail. The whole ecosystem begins to unravel.
And hey, don't think we're off the hook. There was this amazing study back in 2013. They put people in a lab with 0 light cues, completely isolated. And they still found that around the full moon, people took longer to fall asleep, they slept less, and their deep sleep was way down. It turns out we have this ancient circle-lunar clock just hardwired into us.
So what's the verdict here? A moonless Earth might still be in the habitable zone, technically, but it would be a violent, unpredictable, and pretty miserable place to live. And before we wrap up, we have to bust one really common myth.
A lot of people think the moon is like our cosmic bodyguard, right? Blocking asteroids for us. But that's just not really true. Statistically speaking, the moon is a tiny target. The odds of it actually intercepting an asteroid headed for us are about 1 in 160,000. It's not a shield. Its real value is something else entirely.
The moon is really 2 things for us. It's our history book and our gateway to the future. Think about it. It has no atmosphere, no geology to speak of, so its surface is this perfectly preserved 4.5 billion-year-old record of the solar system, a history that's been completely wiped clean here on Earth. And for the future? Its craters are packed with water ice, a critical resource for space exploration. It's the essential stepping stone we need to get to Mars and everywhere else. So, in the end, the moon is so much more than just a pretty light in the sky. It stabilized our world, it gave us our 24-hour day, it drives our oceans, and it set the beat for life itself. It's been Earth's silent partner for billions of years. And you have to wonder, without it, could the world we call home even exist at all?